Hello and welcome to a general problems mechanics walkthrough. We're going to be looking at a question involving a rolling hollow pipe. Let's have a look at the question. A hollow pipe of mass m rolls down a slope without slipping, descending through a height of 10 meters. The pipe starts at rest at the top of the slope, and at the bottom of the slope, its center of mass speed is 10 meters per second. Find the ratio of the inner radius of the pipe to its outer radius. Note the moment of inertia for a hollow cylinder is given by I equals 1 over 2m r squared plus r squared. So let's draw a diagram first. Here is our slope, and it has a height of 10 meters. And at the top of our slope is our hollow cylinder, which is at rest at the top of the slope, and its final velocity is 10 meters per second. We want to find the ratio between big R and small r, aka small r divided by big R. So we're going to use the conservation of energy, and we're going to say that our gravitational potential energy is equal to our final kinetic energy. So our gravitational potential energy is just simply mgh, and our final kinetic energy is our kinetic energy and our rotational energy. And these are given by half mv squared plus half I omega squared, where I is our moment of inertia and omega is our angular velocity. But our I, as is given to us in the question, is 1 over 2m big R squared plus small r squared. So we can sub this into the equation, which gives us this, and we can equate the two, is what we've done over here. We've got mgh equals our kinetic energy and our rotational energy. We can cancel our mass across, which means we get simply gh equals this expression. But notice that because we're not slipping, our velocity is equal to the radius of the pipe times by the angular velocity. So we can sub this in to our v squared at the start, which gives us 1 over 2 r squared omega squared at the start. Next thing we're going to want to do is times out the brackets. So our omega comes in and our 1 over 4 comes in to the bracket, which gives us this nice looking equation. And we can put together our two r squared omega squareds. We can add those and we get 3 over 4 r squared omega squared. And here we times both sides by 4 to get rid of the fractions. Next thing we're going to want to do is take a factor of omega squared out of the left-hand side, right-hand side, and times it into the left-hand side. And then we are going to rearrange and move our 3r squared onto the left-hand side. And here we can divide by r squared. This gives us 4gh over omega squared r squared minus 3 equals r squared over r squared. Now, r squared over r squared is what we're trying to find. And we have a lot of the values here, but we don't know what our big R squared is. Fortunately, V is big R divided by omega, times by omega, sorry. So we can times that right into the equation, which gives us 4gh over V squared minus 3 equals our ratio. Now, we can rearrange and take a square root, and everything in that square root are things we know. G is simply the 9.81, h is simply 10, and our v squared is also 10. So we can sub that into the equation over here, and this gives us an answer of 0.96, which means that our ratio of big R to small r is 1 to 0.96. Thank you very much for watching. If there weren't any steps that weren't clear, please let me know. And if I've made any mistakes, also, please let me know. Thank you very much for watching.